is some of the stuff we'll be looking at today. Starting off with a very difficult problem here. Dividing 168 by 6. So, using long division, how did we do this? So 6 goes into 16. So that 2 times 6 was 12. And then what did we do? Subtracted 12 from 16, giving us, dropping down the 8. I'm sorry? So 6 goes into 48, or 6 times 8 gives me that 48. Subtract, I wind up with a remainder of 0. So in other words, we have our 168 divided by 6 gives us answer 28. No difference, folks. No difference. We don't treat it any differently than the example before. So here, I have x cubed minus 2x squared minus 5x plus 6, and I want to divide by x minus 3. So, set it up like our long division. When I'm doing that long division, I want to do the exact same stuff, but here I'm only concentrating on that first term. I'm only concentrating on my x in the divisor, not the minus 3. And likewise inside, with my dividend, I'm only looking at the very first term. So we ask ourselves, what does x need to be multiplied to come up with x cubed? X squared. So I'm going to place that over the same position. So x squared times my divisor, x squared times x is x squared times a minus 3. What did we do before? All we did was multiply. What is x squared times x minus 3? Write it down on the paper. So what do we do now? We subtract. So subtracting is what? Subtracting just means I'm changing my signs, right? So minus plus, x cubes are gone. I'm left with negative 2x squared plus 3x squared, x squared. What do we do now? Drop down the next term, minus 5x. Repeat the process. X times what gives me x squared? Plus x. So now I take x times the entire divisor, right? So x times x times the minus 3. Subtract, it's the same thing as just changing the signs. First terms are gone. Minus 5x plus 3x. Minus 2x. Bring down plus 6. Nice thing to do. How do I get x to look like minus 2x? So negative 2 times my x minus 3. Once I subtract again, I just change the signs and come up with that remainder of 0. Right? So here, we take in that x cubed minus 2x squared divided by x minus 3, and it equals squared plus x. Is it plus 2? Minus 2. So here we had our, what is x cubed minus 2x squared minus 5x plus 6 called? A dividend. X minus 3 was my x squared plus x minus 2. My divisor, my dividend, and my quotient. I'll be mentioning those terms quite a bit. Divisor, dividend, quotient. So we did this. My dividend, that x cubed minus 2x squared minus 5x plus 6 divided by that x minus 3, giving us this quotient. Or if I multiply both sides by the divisor, what did we just do? We just took this polynomial and factored, or come up with at least one factor. We can use this, and also tomorrow we'll talk about synthetic division, using the division to come up with factors of higher degree polynomials. It's a useful tool. So let's look at another one here. 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. So how do we start this off, Jordan? Covered in the purple.
So you get 6x cubed.
Absolutely. So we do what? I want my x to look like 6x cubed.
Oh, 6x cubed.
Absolutely. So now I take that 6x squared and multiply it by to my divisor. Giving us what, Jordan?
6x cubed minus 12x squared.
Absolutely. So once we have that piece, what do we do next, Jamie?
You subtract
Okay.
minus the plus, and you get 7x squared. Negative 7x squared. Plus 6x.
Absolutely. Get that negative 7x squared. Drop down that next term. That plus 16x. Marissa? So now we want that x to look like negative 7x squared.
Minus 7x.
Absolutely. So minus 7x times my divisor gives us what?
Negative 7x squared minus 14x. Oh, plus 14x.
Absolutely. We get that negative 7x squared plus 14x. Jordan?
And then you subtract that, and then
So my signs change.
it gives you 2x, and you bring down the plus 4.
Absolutely. 2x, and then we have that minus 4. Leaving us to do what, Stefan?
Multiply by 2.
So my plus 2. 2 times that x minus 2 gives us what, Stefan? So what am I going to write here? 2x. Absolutely. So then when we finally divide, or excuse me, subtract, signs change. Once again, I come up with a remainder of 0. So here, it asks us to divide a third degree polynomial by x minus 2. My answer is just quotient of 6x squared minus 7x plus 2. It evenly divided though, right? I came up with a remainder of 0, which means I can express this dividend of 6x cubed as what? Absolutely. This is the same thing as x minus 2 times 6x squared minus 7x plus 2. Another way, again, looking at our factors, or knowing what one factor is, I can break my polynomial down to at least 1 degree less. Here's another tough problem. Yeah, I guess it was a tough one. Using long division for 4 and 139. 4 goes into 13. 3 times. Subtract, I get that 19. 4 goes into 19. I have that remainder of 3. So 139 over 4 came up with a quotient of 34. And my remainder we write as 3, remainder over the divisor. So 34, 3/4. All right. It's just long division. You already know how to do that. We do the exact same thing with polynomials where the remainder is not 0. So here, we have x plus 1 dividing into x squared plus 3x plus 5. Parker, how should I start this off? Absolutely. To get x to look like x squared, then multiply by x, giving us x squared plus x. Kendall? So with the subtracting, the signs change, giving us what? 2x and bring down to 5, all right. Emilio? I want x to look like 2x.
X not like 2x. I don't know what we're seeing.
What do I multiply x to get 2x?
Oh, you multiply by 2, right?
So 2 times x plus 1 gives me?
What'd you say? 2 times x plus 1 is 2x plus 1.
2 times 1 is?
Oh, 2.
Hmm? So we get that 2x plus 2? Or no? Giving us what? So here, with this division, we have our x squared plus 3x plus 5 divided by x plus 1. We came up with absolutely. As Jordan said, plus the remainder over the divisor, so plus 3 over x plus 1. Just like you do in any other normal long division where you have a remainder. Yes? I can also rewrite this as, if I multiply by the divisor, multiply by my x plus 1, both sides, left side becomes what? The original polynomial we started with, right? So I multiplied this side by x plus 1. So we can also express this, if the remainder is 0, it just becomes a nice factorization, right? if I have a remainder, I still can write it as this, as the original polynomial, plus the divisor times the quotient. This is just the division algorithm. The division algorithm, I'll be thrown off by all these letters here. Yes?
So if we leave it as x plus 2, 3, or remainder 3 over x plus 1, is that wrong?
The problem here just said divide x squared plus 3x plus 5 by x plus 1. Just as Jordan gave us, the answer of just x plus 2 plus 3 over x plus 1 would be your answer.
Okay.
This is a segue into where I'm going with this. So, the division algorithm, if f of x, the original polynomial we're starting off with. So if f of x and d of x is just my divisor. Our polynomials where, of course, I can't be dividing by 0, so d of x is not equal to 0. And the degree of d of x is less than or equal to the degree of f of x. What does that mean? Again, d is my divisor and f is my dividend. Should be with who? Should it be with my divisor or my dividend? Dividend. In other words, you don't want to have a higher degree divisor dividing into my dividend. I can't do x to the 5th plus 1 dividing into x cubed plus 2x. Right? It's going to be the other way around. So that's what this is saying here, is that the degree of your divisor is less than or equal to the degree of your dividend. Then there exist unique polynomials, q of x, my quotient, and r of x, my remainder, such that f of x, my original polynomial, is equal to the divisor times the quotient plus the remainder. Exactly like we have written over here. This is my f of x. This is my divisor, my quotient, my remainder. That's all this is saying here, folks. As far as we're always going to wind up, there's a unique divisor and a unique quotient and remainder such that this happens. If r of x equals 0, then we say that d of x, my divisor, evenly divides into f of x. This is just stating the division algorithm, folks. I'm not going to ask you what is f of x, what is d of x, what is q of x. Just understand, this is the type of stuff, like in the previous example, this is what we can wind up with. We're going to have a quotient times our divisor plus a remainder. Coming up with a remainder of 0, we have a nice even factor. Coming up with a remainder that does give us some useful information, which we'll talk about tomorrow. So, before we apply the division algorithm, we have to, with the dividend and divisor, we need to put it in descending power order. Right, so if I had I would not leave my dividend or divisor like that. We would first put the 3x to the 7 in the first position, right? And then the x to the 5th minus 1. That's all that's saying. And then also to insert placeholders. With 0 coefficients for missing powers of the variable.
You could put like, for that one, you put like plus 0, 6, I mean, plus 0x to the 6.
Absolutely. Just as Jordan said, because let's say we had something like this. Let's say we're going to divide x to the 4th minus 1 by x plus 1, and we did not put in those placeholders. So we just did this. So, what do I multiply x to get to x to the 4th? x to the third. So x to the third times all of my x plus 1 gives me what? X to the fourth plus x to the third. And now we subtract. My x to the fourth is gone, right? But what's going on next? Negative 1 in x cubed. I can't do anything with that. We don't do this, folks. I don't know why you guys were copying that. I already said this is why we do not do this, folks. So as Jordan told us, we're going to put in wherever those missing powers are. So starting off, I have my highest degree, putting them in, again, descending power order. It's already set up that way. X to the fourth. Which powers am I missing? I'm missing the third, the second, and the first. So if the constant is missing, make sure you put a 0 in for your constant as well. Right? If we didn't have that minus 1 and it was just x to the fourth, put in a 0 for that very last term as well. Now that we have those placeholders in, everything will match up when we add or subtract vertically. So here, it says before you guys told me x cubed. So x cubed times the x plus 1 still didn't change. It's still. But now when we subtract, now everything is lined up, right? Our x to the fourth term is gone, and we have what now? Negative x cubed. And drop down the absolute plus 0x squared. So from here, we just continue on. Or I should say, Ethan will continue on. What do we do next? Positive or negative?
Negative.
Because we want it to be identical to this, absolutely. So negative x squared, giving us what?
Negative x squared plus
Hmm?
order cubed
Mm-hmm.
plus x squared minus x squared.
Absolutely. And from there, Nick, what do we do?
Subtract it, so this versus 7. So x cubed plus x squared.
Absolutely, absolutely. From there, Cullen?
Multiply by x.
Absolutely. To get x as x squared, as Cullen said, we're going to do a plus x, giving us what, Cullen?
X squared. So
Absolutely. And Mallory? Negative x, and we do what? Absolutely. Haley?
Multiply it by over negative 1.
Giving us what?
Negative x.
Lining up with our remainder of 0. So here, putting in those placeholders, that x to the fourth minus 1, dividing by x plus 1. That's the whole problem. That's what it asked you. My answer is just that quotient. Plus the remainder. There's a remainder in this case. There isn't, so it's just x cubed minus x squared plus x minus 1. So again, this is for my x fourth minus 1, it's the same thing as x plus 1 times x cubed minus x squared plus x minus 1. It's a way that we can use it as a factorization. Does everyone understand what I'm saying with that? Let's do that. Tori, anything different with this problem?
Yeah.
Do we solve it any differently? I don't know. I should have rephrased it. Just a little bit more writing. In this case, we have a trinomial as my divisor, right, versus a binomial. I don't treat it any differently. I'm always just looking at that first term. So what do I do?
The first one,
Absolutely. Giving us what? Absolutely. So we get that 6x to the fourth plus 6x cubed minus 6x squared. What do we do next, Blake?
Subtract. So this one's all on. So you get negative 7x cubed. Plus 5x squared. And if you break it down,
Absolutely. Get that negative 7x cubed minus 5x squared plus 9x. Brandon?
You want it's going to be minus 7x.
Giving us what?
That is going to be negative 6x cubed plus negative 5x. Negative 7x.
7x squared.
Minus, minus 7.
Plus 7x, right? So, right. Multiplying by negative 7x to that divisor. Negative 7x cubed, minus 7x squared, plus 7x. From this we get, what, Heba? What do we do now? Subtract. All right.
Says 2x
Mm-hmm.
plus 2.
Let's back up a sec. This should be a plus 5x squared, right?
yeah, that was freaking me out.
Yeah. I was going to say, that doesn't look too right. So,
Ooh, that was crazy.
negative x squared plus 6x squared gives us a positive 5x squared. So now we get, right, so 12x squared so we get that 12x squared plus 2x minus 3. Everyone checking on that? Yes. Fernando? Now what?
Did you multiply by 12x? No. 12.
So you can make x squared into 12x squared, positive 12. So doing that positive 12 to my entire divisor gives us what?
It'd be 12x squared plus 12x minus 12.
Sorry?
Minus 12.
12x squared plus 12x minus 12. And lastly, Michael?
Minus subtract.
I'm sorry?
You're left with 9.
Oh, wait. 2x and a negative 12x.
Negative 10x.
Do I go any further? Why not? How do I know that's my remainder?
Because x squared is on the outside and you can't divide 10x by x squared.
Once my divisor is a higher degree, I know I'm done. My divisor was a second degree, and what we're left with over here is a degree of 1. So here, we have that 6x to the fourth minus x cubed minus x squared plus 9x minus 3 divided by x squared plus x minus 1 is equal to 6x squared minus 7x plus 12
Square.
plus 1 or minus 1?
Minus 1.
That would be your answer for this division problem. Doesn't evenly divide, so definitely tells us that x squared plus x minus 1. It's not a factor, but for whatever reason, if you needed to divide, you're going to find out tomorrow why we actually look at the remainder sometimes. I know you have a question.
So you're saying when the power of that x, if there's
Divisor,
the divisor on that number is bigger than that,
you're done.
then
Questions? I still have more sticks on that now.
Wait, I have a question. Will there ever be a time, well, it doesn't, but like, will there ever be a time when the, divisor is like missing one of the things? It is?
Oh, I wasn't in that one. This one it doesn't specifically say, but you should put in your placeholders into both divisor, and that's a very
Okay,
good
so it
question.
just like works the same way?
Absolutely.
Okay.
Folks, did you hear that question? Very important question. You will see that in the homework. Don't just use your zero coefficient placeholders for the dividend. Works for the divisor as well. If you are missing something, again, you have to put them in descending order. Missing something for either one, the divisor or the dividend, put in those zero placeholders. It will make your life a lot simpler. All right, last one, folks. Four more. And all four are here. So, I should have someone else come up here. This is a lot of writing. So, how do we start this off? Carolyn.
you have to multiply it by 2x squared.
Okay, absolutely. First, we're just looking at those first terms. So by 2x squared, what do we get? 4x who?
Squared.
4x who?
Oh, cube.
4x cubed?
And then 6x squared.
Plus minus? Erica? So all my signs change? Giving us?
X, I don't know, positive x squared.
Now normally that would be true, just bring it down to 3x, but that's when we are only dealing with a binomial. But since we are dealing, our divisor has 3 terms, we want to make sure we have 3 terms for it to be set up with, right? So not just dropping down to 3x, but I also want to drop down to minus 2, right? So that all 3 of these will be able to match up with something. Everything else we did before, we were just dividing by a binomial. So now that we have that x squared plus 3x minus 2, Becca? I have to multiply it by something, so by what?
1. Positive.
Positive 1, giving me what?
Squared plus 2x.
And easy. So what would my answer be for this division problem? How would I write it out? They said to divide. So what is the answer?
X squared plus 2. I did the wrong one first one.
That's all right. Well, my answer is always going to be what? This is my divisor, this is my dividend. My answer is always going to be the quotient plus the remainder, right? So where's my quotient?
2x squared plus
And then my remainder was
x squared.
x.
X plus 1 over x squared plus 2x.
Good. We always list that remainder over our divisor. So in this case, this particular division problem, we come up with 2x squared plus 1 plus the remainder over that divisor of x squared plus 2x minus 3. Questions on that?
Why did we bring the minus 2 down again at the x squared plus 3?
Because here we have, in our divisor, we bring down that minus 2 because our divisor has 3 terms. All the other examples we did, and this one we always had 3 as well, right? But we are
3 terms on the divisor if we want 3 terms on
exactly because we want to match up each of those terms. So if for some reason I'm dividing, my divisor has 4 terms, I always want to make sure I have 4 terms to compare it with. It's just that in this one we canceled out 2 to begin with, so we were only left with 1. Right? So would you guys like to practice now?
Yes.